Hello, we're having a look at Advent of Code 2018 Day 7. This is really just a shakedown to make sure everything's going to work for the real Advent of Code this year. Day 7, the sum of its parts. You find yourself standing on a snow-covered coastline. Apparently you landed a little off course. The region is too hilly to see the North Pole from here, but you do spot some elves that seem to be trying to unpack something that washed ashore. It's quite cold out, so you decide to risk creating a paradox by asking them for directions. Oh, are you the search party? Somehow you can understand whatever elves from the year 1018 speak. You assume it's ancient Nordic Elvish. Could the device on your wrist also be a translator? Those clothes don't look very warm, take this. They hand you a heavy coat. We do need to find our way back to the North Pole, but we have higher priorities at the moment. You see, believe it or not, this box contains something that will solve all of Santa's transportation problems. At least that's what it looks like from the pictures in the instructions. It doesn't seem like they can read whatever language it's in, but you can. Sleigh kit, some assembly required. Sleigh, what a wonderful name. You must help us assemble this sleigh at once. They start excitedly pulling more parts out of the box. The instructions specify a series of steps and requirements about which steps must be finished before others can begin. Your puzzle input. Each step is designated by a single letter. For example, suppose you have the following instructions. The first goal is to determine the order in which the steps should be completed. If more than one step is ready, choose the step which is first alphabetically. In this example, the steps will be completed as follows. Only C is available, and so it's done first. Yep, fine. Finally, E is completed. So in this example, the correct order is C, A, B, D, F, E. In what order should the steps in your instructions be completed? That sounds straightforward enough. Maybe silent contemplation. Okay. This says, okay, be completed for step B. Begin. So if S is 0, then we're at 1, 2, 3, 4, 5. So that is 37. So from position 0, if I go 5L, I get to A. If I go 37L, I get to B. So we want a map saying what they require, and I might simply index it with no, we'll do it with letters. This wants to be 26, 26, which says which one requires which other one. And we've got done, which says which ones we've already completed. So now we've got step and requirement. So requirement is line 5, step is line 37. And we know that is this requirement, is this step, requires step rec, and that's all. And then to to solve it, while any jobs exist, we will do one job. And it said do the one that's first alphabetically if we can. So if we can do job I, then we should do job I. It's not really num exists, it's num to do. And we can't do it here. Actually, we don't even need it. We'll just while one job. And then if this finishes without finding one, then we're finished. So if we do it, if we can do it, then doing it involves marking it as done. And that's all. Marking it as done and printing it out. And returning it. So how do we find out if we can do it? We can do a step if all of its prerequisites are done. Actually, I might just do if not exists step, or if done step, then we can't do it again. So if step requires I and not done I, then we can't do step. And that might be all. Let's get the sample input out. Right, I'm back. I should really do something about that. The problem is that the library code includes a variable called line. Closing brace. Oh. A, B, C, D, F. I do not think that is correct. Should be C, A, B, D, F, E. Did I get my letter indices as well? So that's 36. I think I wrote completed instead of finished. CAB, DFE, very good. OCPU, EFIX, HR, GWD, ZABTQ, JYMN, KBSL. OCPU, EFIX, HRGW, DZAB, TQJY, MNKVSL. Good stuff. Does it get to? Part 2. As you're about to begin construction, 4 of the elves offer to help. The sun will set soon, it will go faster if we work together. Now you need to account for multiple people working on steps simultaneously. If multiple steps are available, workers should still begin them in alphabetical order. Each step takes 60 seconds plus an amount corresponding to its letter. A equals 1, B equals 2, and so on. So step A takes 61 seconds, while step Z takes 86 seconds. No time is required between steps. To simplify things for the example, suppose you only have help from 1 elf, and that each step takes 60 fewer seconds. Then, using the same instructions as above, this is how each second would be spent. C takes 3 seconds, A takes 1 second. Each row represents 1 second. The second column identifies how many seconds have passed as of the beginning of that second. The second column is not the first column. Each worker column shows the step that worker is currently doing, or dot if they're idle. The done column shows completed steps. Note that the order of the steps has changed. This is because steps now take time to finish and multiple workers can begin multiple steps simultaneously. In this example, it would take 15 seconds for 2 workers to complete steps. With 5 workers and 60 plus second step durations, how long will it take to complete all of the steps? Okay, I have to give that some contemplation. Do we print out the order that the jobs are completed or the order that the jobs are started? It actually doesn't matter what order we print them out in. Back again. I haven't got the baby anymore, so shouldn't be interrupted again. But while I was trying to sort out, I think I figured out how to do it. I'm going to make an array that says for each of the 5 workers when he's next free. And when a worker starts a job, we'll simply say, we'll pick the worker who's next free soonest, and we'll say that worker is then next free once that job is finished. So if a job can be done, yes, do this, but also work on I. What work on will do is, well, choose the worker who is next free soonest to update his next free time. So that's going to be next free worker equals next free worker plus 61 plus step. And then at the end, instead of that, we want to go through each worker and work out when they're all done. Oh yeah, when they're all done. If next free I is greater than all done equals next free I. Okay, that'll tell us when the final worker has finished his final job. So find out which worker is next free soonest. And that may be all we need. Well, the rounds are too low. So what I might do is make it print out what it's trying to do. I think that looks right actually. Next free all gets initialized to 0. And we print the time that the last worker finishes work. Might read the problem again. Each step takes 60 seconds plus the amount corresponding to its letters. So RA is 0, so it's 61 plus the index. Oh, you have help from one elf with 5 workers. Is that 5 elves helping me? Why would that make it take longer than my... Step C doesn't count as done until all the time has elapsed. Okay. So instead of writing 1 into done, what we instead do well, what we instead do is we'll say that the step is done when the worker has done it. So we want to know the earliest that it can be done. not simply whether it can be done now. So when we return 1, we'll also set the earliest time it can be done. So we'll work on now takes Now this might not give us the right answer because we'll always pick the worker who is next free soonest to work on this job, and that's not necessarily the best choice. But we can submit it, see. Too high. So what we want is not the worker who is next free soonest, but the worker who is next free least soon, but before the starting time. I'm going to have a think about this. Yeah, we'll have the one that's free soonest, but we will pick the job that is next available to be started soonest. So we wanted the worker who's free soonest, but instead of just doing the first one alphabetically, we'll do the one that can be done most soon. That's a bug in my editor. I got rid of special rendering for tabs because it slows down. Oh yeah, I've just done it again. Because it slows down the rendering. But I forgot that my indent input inserts tabs. So that needs to insert 4 spaces instead. So yes, if do step is -1 or earliest is less than do earliest, then do step equals I and do earliest is earliest. Yeah, let's try that then. Same answer. So that is incorrect. think the problem is that a worker can become free and has enough time to do another job, or at least should be doing another job before this job starts. So if worker A becomes free and then worker B becomes free, and we say worker A has to work on it because worker A became free first, that's not right. What we really want is the worker, if the worker becomes free before the start time, we want him to be the latest one. If he becomes free after the start time, we want him to be the earliest one. We would prefer a worker come free before the start time of the job. Right, so preferences are the worker becomes free before starting time, and we want the latest one. Failing that, pick the earliest worker. So if this guy comes free before the starting time, then we want him to be the later one. Okay. Wow. So, how do we work out if we want him? If he becomes free before the starting time, and the other guy also became free before the starting time, why am I finding this hard? If the other worker became free after the starting time, then we simply want this one. So we want to replace if next free is greater than him, or he was greater than starting. Otherwise, pick the earliest worker. Try that. How long is it going to take? 61 plus step. Okay, well. We're always using worker 0. Why are we always using worker 0? Well, for the second job we attempt to do, worker ID 1 will have next free set to 0. So that will either be less than or equal to starting. It will be less than starting because start time would depend on the completion of the first job, maybe. Well, either way, it looks like it should be replaced. Say which one we want. Yeah, never decides want. If the next worker becomes free before the starting time, then if that worker becomes free at a later time than the worker we've already found does, which he doesn't, or the other worker becomes free at a greater time than the starting time of the job, it always thinks the next job it needs to do starts at the exact time the worker becomes free, which suggests that it's a linear progression of dependencies. Why do we think that? So can do right into earliest. The earliest time. We were assuming it depends on every job. That's the problem. And if it depends on every job, then it does become a linear stream of dependencies. Okay, this is looking better. Whee! Great success. Took a bit longer than expected, but that's life sometimes. I think having the baby in the room with me is not going to be a good way to do Advent of Code. Although, obviously, I can't blame the baby for my poor thinking. Anyway, that's that. Thanks for watching. Goodbye.